To investigate the parallelogram, what we're going to do is start with a triangle and rotate it about its midpoint. So if I was to rotate this about its midpoint, it would kind of land right about here. And guess what's formed? We form a quadrilateral when we rotate a triangle. And some things are found out when we do that, that these opposite angles would be equal, these angles would be equal. We learn that opposite sides are equal in that relationship. And we learn some things, we learn about consecutive angles, that this group of angles and this together add to 180. Why? Because we get some parallel lines when this happens. And we know that the same side interiors are equal. And we learn that if we drew in this diagonal, that it cuts this into two equal pieces. And the other diagonal right here gets cut into two equal pieces. Lots of things that are happening there. Let's look if we started with a different guy. In a similar way, if we started with this right scalene and then we rotated it about its midpoint, it would land kind of in this position here. And because of that, I can see some new relationships that are formed. Again, I see that parallelogram formed. I see the same relationships where the opposite sides were equal. I see that same relationship where the opposite angles all matched up. I also see that same one about the diagonals. Look, if I draw in the diagonal, I find out that this little piece and this piece would be the same, and this part of the diagonal and this part of the diagonal are congruent. We keep seeing the same relationships showing up. If I was to rotate about M on that side, it would kind of look like this when I'm done. And again, it would form a parallelogram in shape here. We would find that the opposite sides are indeed equal to each other. We would learn that the opposite angles match up in all of those cases. And again, we would be able to learn that the diagonal of this guy would bisect each other. So whatever this one is, it would match, and this one would match this one. So this idea of starting with a triangle to obtain a quadrilateral is quite cool. And by looking at it, we're able to see inside at what's actually happening. Let's record all the things that we saw. In a parallelogram, the opposite sides were parallel. The opposite sides were equal. They weren't perpendicular, so these guys are not perpendicular to each other. No. Were all of them the same? No. Were the opposite angles equal? Yes, we always found when we were done the opposite angles were equal. And are the consecutive ones, that would mean this one and its next one, are they supplement? Our answer to that is actually yes. The reason for that is, remember, these are parallel lines, and we learned that the same side interiors would be equal. So that actually will always be true, the consecutive angles. These two would be equal to 180, so would these, so would these, and so would these. Consecutive angles do always add to 180. And are the four angles the same? Absolutely not. Now, how about diagonals? So let's take a look. Remember what kept happening with the diagonal, this one and this one? What kept happening is that it would bisect or cut the diagonals into two parts. So yes, that would always be true. Will they always be equal? No. Will they be perpendicular? No. Are they angle bisectors? No. So, pay attention here, these are important. Opposite sides, parallel. Opposite sides, congruent. Opposite angles, congruent. Opposite or consecutive angles, 180, and they do bisect each other. When you work with a parallelogram, you are going to need to remember each of those relationships. This guy, these two, and these two. Let's apply this now to solve some problems. Here, I'm going to use information about a parallelogram about its sides. So I know those two are equal, and I know these two are equal. So ultimately, I can set up two little equations. I could say 3x minus 14 equals 22, and 3x equals 36, and we get x equals 12. In the other case, we would say 3y plus 26 will equal 5y plus 6. Gather over here, we get 2y over here. When we move over the 3, we get 10 over here, and y equals 5. So again, I'm using my knowledge about parallelograms. These have to be equal, and these have to be equal. Use your property to solve the problem. All right, let's take a look here. Now there's no sides or lengths. This is all about angles. So I notice this angle is 41. And I do know that this is parallel to this, and so this transversal runs through here. That tells me that this 41 must also put 41 there. So x is 41. In a similar way, I think I can track down the y value. I would say that I know this is parallel to this. This is a transversal, and so can you see that these are alternate interiors, that this guy and this guy here are alternate interior, so that guy would be 22 as well. So here, I just use the fact in a parallelogram, you're going to get parallel lines, and you can use alternate interiors and things like that. More about angles. I see this 105, so I think I know y is 105. So let's put that down. Let's see, I see that this 48 would be alternate interior to x, so that would also be 48. Now z is like just out here, but I do notice that this is a triangle, just any old triangle. And I notice that it's got a 105 and it's got a 48. And so what's left of that would be 27. So again, I'm just using, in this case, just what I know about a triangle. I didn't have to do much about the parallelogram at all at that stage. All right, it wants to know x. I can do that. I see 46 here. That would mean this is also 46, so I've got x already. Now let's look at this angle. Where is this? BCD. That's this whole angle here. I see what I need to do here. Well, I know that this angle would match this one, but I don't know anything here. But I also know that this angle here on the right, this one here, and this one here together are consecutive, and they would add up to 180. So this corner is a 66 here, and that would leave for me 114 for the other corner. So here I'm using the fact that they are together consecutive angles there. And actually that helped me to answer the last question, which is angle C, B, A here, which happens to be that 66. So I'm putting together lots of things, but can you see how you use the properties to physically solve for angles and sides?